We are to our final lesson of this unit, so please make sure that you do your review on Pearson's SuccessNet. Once again, Mr. Sullivan is here to tell us about the parallel postulate and the triangle sum theorem. Take it away, Mr. Sullivan.
And it burns, 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 the ring of fire, the ring of fire.
Alright, welcome back. Parallel lines and triangles. So we got a postulate. Remember, this is something that you just kind of have to accept as true. We can't really prove it. It's one of the basics of geometry. Through a point, not on a line, there is one and only one line parallel to that given line. So if we take a look at it, what's that saying is this. Let me get a line up here. If we have this line right here, boom, there's only going to be one line through that point that's parallel. If I have another line that goes through there, that's a little bit exaggerated, but no other line will be parallel to this line and through that point. There's only going to be ever one possibility for that, all right? Just one of those things that, it kind of makes sense when you see it, but we can't really prove it because it's a postulate. All right, so today we're going to talk a lot about triangles and the angles related in there. All right, so what are the angles? If I added all these angles up, 1, 2, and 3, what would this sum be? Well, let's take a look here. So this is angle 2. I'm going to try and rotate this. This hopefully will work. Okay, we'll get it right there. And bring angle 3 over here. So we have angle 1, 2, and 3. Now, this makes a straight line right there. Let's make sure. Straight line through there. So how many degrees are in a straight line? Well, we know there's 180, which sounds like a theorem. It's the triangle sum theorem. It's a big one. All right. The sum of the measures of the angles of a triangle is 180 degrees. Any triangle you have, the sum of these three angles is going to add up to 180 degrees. 180, huge number in geometry, right? It's come up several times already. Supplementary and all that stuff. So this is another time it comes up big. All right, let's prove this. Given that we have this triangle and we have this line parallel to this line, we want to prove that the angles inside measure 180. So number one, let's start with the given. Triangle XYZ and YA parallel to XZ. That is given. All right, number 2. Let's talk about this. This here's a straight line. That's 180 degrees, but we can't just say that. So we have to pair some things up because a linear pair is 180. We have 3, not a pair. So let's group these two angles together. So angle AYX and angle 4 are supplementary. All right? And that's angles that form a linear pair are supplementary. Okay? So we now have this and that equals 180 degrees. All right, so let's see here. So we know that's 180 degrees, like I said, so let's write that out. So the measure of angle AYX plus the measure of angle 4 equals 180. And that's just the definition of supplementary angles. Number 4. Now what is AYX? AYX is 5 and 1 together, right? So we should write that down. Angle AYX is angle 5 and angle 1. And whenever we add angles, that's the angle addition postulate. What else can we do? Well, we know that this is 180 degrees. Let's substitute in. So let's do the measure of angle 5 plus the measure of angle 1, because that's AYX, plus the measure of angle 4 equals 180, and that is substitution. All right. So now let's take a look at this. Angle 5. Angle 5, these are parallel lines, so angle 5 and angle 3 are congruent. So the measure of angle 5 equals the measure of angle 3. And also, angle 4 and 2. Measure of angle 4 is equal to measure of angle 2. And the reason for that is because they are alternate interior angles, right? So if two lines are parallel, then alternate interior angles are congruent. Alright, that's awesome. So now let's plug these in. Instead of angle 5, let's put angle 3. The measure of angle 3 plus angle 1, we didn't have any change for that, plus angle 4 is angle 2, equals 180 degrees. And that's what we wanted. 1, 2, and 3 equal to 180. And all we did there was substitution. That's how you do that proof. I know it's a little long and complicated. You often don't see it, alright? I understand that proofs are tough. We're going to do a lot of them this year, so you're going to get used to it. Just hang in there.
With that introduction, I just want to do some quick examples here. What are the values of x and y in the diagram at the right? Let's start by using the triangle sum theorem. If you notice, there is a triangle right here, and angle x happens to be part of that triangle. There are two other angles in the triangle, this 43-degree angle and this 59-degree angle. And these three angles added together have to be 180 degrees. So 43 degrees plus 59 degrees plus x is equal to 180 degrees. Once again, that's the triangle angle sum theorem. So if we add 43 and 59 together, that should be 102 degrees. I'm hoping. Check my math there. If I'm wrong, email me and let me know. And then if we subtract the 102 from both sides of the equation, we should end up with 78 degrees. So I am going to add that right here. Now for angle y, it would be nice if we could use this triangle here. Unfortunately, there's this angle z that we don't know. However, I noticed something here. Angle x and angle y form a linear pair. So we can use the linear pair property, which says that angle x plus y has to equal 180 degrees. But we already know that x is 78 degrees. So therefore, subtracting 78 degrees from both sides of the equation, we find out that y has to be 102 degrees.